Okay, so as mentioned, you'll need your notes notebook today. We will be taking notes. Or you can write in your IDS practice book. There's plenty of usable pages and empty pages for you to take notes with between pages 59 and 66 for lesson 11. You'll need your journals for 1.2, okay, open in your Google Drive, and you'll need your Canvas open to the Unit 1, Section 2 page, okay? All right, so lesson 11 is about what shape are you in? Now, considering the fact that we've been collecting data on our food habits and our snacks that we're eating, you would think that this is literally about what shape you're in, right? It's not, okay? This is about the shape of histograms. So we are going to be looking at histograms and the shape of the histograms. Okay, our objective and our essential concepts for the day are the following. Our objective for the day is that students will learn to classify distributions in terms of shapes and can suggest theories for why a distribution might be one shape or another. Okay, our essential concepts for the day is identifying the shape of a histogram is part of the interpret step of the data cycle. Okay, so we can analyze, right? Data analysis is when we create a histogram with our data, and we'll learn how to do that in our studio. But the interpret stage, that final stage where we are trying to interpret our data to answer questions, right? Being able to identify the shape of a histogram will allow us to answer questions about our statistical question. It'll help us answer the statistical question. So we need to be able to accurately and using proper vocabulary interpret the histogram so that we can actually answer our question. Okay, I'll give you guys 30 more seconds because I think some of you like to write down the objective and the essential concepts here, which is a good thing because then that lets you know exactly what the goal of the lesson is. Okay. Okay, so what we are going to be working on today is we haven't actually done breakout rooms in quite some time. Okay, it's probably been like 2 or 3 weeks by now. And we are going to be doing some group work and some breakout room work today. So you will be working in a group to sort histograms. Okay, the goal of the sorting is you are to sort them based on their shapes. So basic directions here, you will be given 24 histogram images, okay? You can see what type of data is being measured on these histograms. So it's labeled. So our horizontal axes, our x-axis, gives us the whatever's being measured. So it gives us what the data is about, right? And in what units it's being measured. So that's our x-axis. Our y-axis, as always, will give us the frequency, how many observations are in each bar, okay? So the x-axis tells us what's being measured. The y-axis tells us the frequency of each bar. You are to sort the plots into different piles according to their shapes, okay? And you have to decide the similarities in the shapes. You're going to be visually seeing what the similarities are between the shapes, okay? So histograms that have similar shapes should be sorted into the same stack, but I'll show you how we're going to do it in a moment, okay? Okay, I refuse to answer anyone who doesn't have their legitimate first and last name as their first and last name. Okay, so if you would like, you are going to be, you can look up the histograms in your IDS book, in your IDS practice book, as I was saying, okay, pages, I believe it's at 59 through 60 something. So notes area for today's lessons can be taken on page 60. But then when you continue flipping the pages, from pages 62 through 65, you have these histograms, okay? You have these histograms. So you can see the histograms much larger on your papers if you want, okay? But I have cut out each one of these. I've cut and pasted each one of these onto the slide. So let me show you where you guys are gonna find this, okay? So let me precede this by saying that for each group, there should be one copy of the slides created, okay? For each group, there should only be one copy created. So whoever the team leader is, okay, you are going to click on the assignment and you are going to open a copy of the document. And then you are going to share that document with your group mates, okay? So if you go to home, Unit 1, Section 2, as you're supposed to be there already, okay? You will see under Lesson 11, okay? Here's our PowerPoint, and here is our assignment, 1.11 histogram sort. So when you click on this, it's going to take you to same directions as was just on the slides, and then over here, each group should make one copy of the 1.11 histogram sort slides and share it with your group mates. One person can submit it for all the group members. So as the groups are created, I'm going to go in and put it in so that you guys can submit it as a group, okay? So here is what you come to. You come to the 1.11 histogram sort. You're going to write your active participating group mate names here. So everyone should pretty much type in their own name. So if you don't type in your name, that's on you, okay? So you're going to sort 24 histograms on slide 3 into the groups according to their shapes. Then you're going to answer the questions on the last slide. Each group of the histogram will be a slide. So it's been modified a little bit. So here are all of the histograms. I've literally just scanned them and then cut and pasted each one. It took me quite a while. So if you want to look at the shapes a little bigger, you can always make your images larger, okay, and view them. But you should cut and paste them instead of copy, so that way you know what's left, right? So cut, you just right click and you can click on cut, or you can do Control X once you select it. And then when you go to each one of these slides, you have 6 slides total for 6 groups. Now, you should use at least 4 groups, okay? It is not mandatory to use all 6 groups, but you should use at least 4 groups. So you should have at least 4 differences in the shapes. But I will say that you can use all 6. You can find differences that would put them into 6 groups, okay? As a group. So you're just going to whatever has the similar shapes, okay? And you are determining what similar shapes are. You are the one determining the similarities. I'm not giving you the similarities. You and your group mates are determining what's similar and what's different, okay? You're going to just cut each picture and paste it on whichever slide you've decided to be that group's slide. When you're done with that, you're going to come over here and you're going to answer these questions here. Describe what's similar about the plots in each group. Okay, pick the best example of a graph from each group. So title of the graph or a copy and paste of the graph will do. Give the group a name that you think describes the general shape. So you can just list here like shape 1 slide, this is what was the similarity. Shape 2, this is what was like, this is the name that I would give it. Shape 3, this is the name I would give it, and so on. Okay. If there are graphs that do not fit into any group, try to determine why it was difficult to place them and what is different or confusing about them. So you're answering these 4 questions, and then you're going to put your answers in your journals for 1.2 as your lesson 11 journal entry. So once you're done with this, you are then going to put these answers in your journals for 1.2. Okay. So you are sorting again based on the shape. Okay. Any questions? Okay, I got some no's from people. No, you may not choose your groups. Mainly because I don't know how to do that. Yes, you're just sorting and answering some questions. Oh, one of you should have had this question. You have a total of 15 minutes to sort and answer your questions. So when you get into your groups, quickly decide who's making the copy, who's sharing it, and start working. Okay? Or someone take initiative. I don't know. Let's see how you guys do the work. All right. So, okay, Dario says he already has a copy, so hopefully he doesn't have. So let us create our groups here. I'm just doing a quick run through of who's in each group. Okay. And a reminder, ladies and gentlemen, okay, and a reminder, if your group mate or group mates are not actively participating, I need you to let me know, okay, because it is not fair that they get the same credit that you do when you did all the work. Okay, it's time to start being a little bit selfish for group work. They haven't given you anything for you to give them a grade. Okay, so please make sure that if they are not actively participating, that you let me know either through a private chat or through an email to my Canvas. All right. Let's see here. Okay, opening all the rooms. Best of luck. Here. So make sure that you remember to answer these questions in your DS journal. They are the same 4 questions that were on the last slide of the histogram sort. So make sure that you also input those answers into your journals. Okay, that is something that needs to be done. So I want us to do a real quick chat, whole class discussion. What can you share about the histogram groupings? What did you notice about the histograms? Okay, well, what's one thing that you noticed in the process of sorting them? Awesome. I want you guys to respond respond in the chat. Oh. Ooh, Tyrese, good observation. One of the groups looks like a bell shape. Okay, many of them look the same in their categories. You can kind of use process of elimination when you don't know where to put them. One group was bigger than the other. Okay, so there were more of one group. Well, depending on how you group them, right, David? Most look similar. You can, I read Katie's, here we go. Some of them look similar in terms of shaping of rectangles. They're similar. Okay, so they might have looked like they had the same bandwidth maybe, or the width, bin width. Most look the same. Okay. In one of our groups, one bar was significantly taller than the rest. Okay, so you looked at tallness instead of like maybe other characteristics. Okay. Some of them had very slight differences in terms of width of the bar. Okay. Width of the bar or height of the bar, Valerie? Because the widths of the bars should be pretty similar. And the heights of the bars, some had similar heights. Yeah. Some had similar heights. Okay. Very good. All right. So taking out our notes notebook. Okay. We're going to now talk about, wait, I went backwards. My bad. There we go. Okay. Each of these shapes that you might have noticed, okay, they have actual names in statistics. So histograms in statistics have names for their shapes that give us an idea of how the shape might look, okay? So Trinity said groups can be organized by shape, bell shape, rectangle, left skew versus right, absolutely. Let's see if, good vocabulary there, by the way, Trinity. Let's see if your definition of left skew matches right skew. Okay, we use specific terminology when discussing the shapes of distributions, okay, such as symmetric. Symmetric is when there is approximately the same shape on either side of the middle. So for example, if I have a histogram here, right, here's my middle, we have approximately the same shape. So those of you that were talking about that bell curve, that's when we have a symmetric histogram, okay, where we have approximately the same look and shape on both sides of the histogram, okay? Right skewed and left skewed, you might think that they refer to the highest bars. In reality, a right skewed histogram is when there is essentially a tail going out to the right, which means the peak happens on the left side and the tail goes toward the right. Okay, so the right skewed is when you have your tail to the right. Left skewed is when you have your tail going out to the left, which means your peak happens on the right and your tail is going out to the left. So right skew and left skew don't have to do with the max. They have to do with which direction your tail is moving in. Okay. Now, these are the basic descriptions for where our peaks might be. Okay, especially if there's a single peak. Okay, especially if there's a single peak. Now, right, the single peak here may happen in the middle there. They can also be unimodal, or bimodal, okay? Unimodal is when you have one clear peak. So any one of these can be unimodal, where you have one clear peak in the middle and then it like goes down like this and goes down like this, where this is your one clear peak. You could have, I'm sorry, I drew that wrong here. You could have a very right skewed unimodal. You could have a left skewed unimodal, right, where you have one clear peak here. There are no multiple high peaks, okay? A bimodal, on the other hand, is when you have multiple high peaks, and then you could have something like this and something like this, okay, where you have two high peaks there. And then, of course, you could have the multimodal where you have more than two, or you could call it a trimodal if it's three, right? And then there's one more word that's not on here. This is called the uniform. A uniform histograms are when there is no clear peak, or they all have similar heights. Okay, so that's when you have a situation where you have something like this. And it's all like pretty similar heights. Okay, that's called uniform. So I'll give you guys 2 more minutes to finish writing this down. Okay, 2 more minutes to finish writing down these vocabulary words here. All right, guys, so I'm gonna clear all these drawings. Okay, and we have a little bit more vocabulary to talk about. Actually, we don't. That's our vocabulary for the day. I apologize for that. Now I want to put it into action a little bit, okay? So I want you to describe the following scenarios using the statistical terms, okay? So we're going to take a look at these scenarios and we're going to try to imagine what the data in a scenario like this would look like on a histogram, where the peak might be, or if there might be multiple peaks. So let's start off with an easy one, okay? If I had the grades for an easy test, let's say you guys took an easy test and we had the grades for that easy test, right? Where do you think most of those grades would be? Would they be on the higher end of the scores, or would they be on the lower end of the scores? Okay, where do you think they might be? Okay, so for an easy test, right, higher end. So then if I draw a histogram here, right, let's say this is 20, 40, 60, 80, 100, right? Most of my grades for that test are probably going to be on the higher end of the spectrum, and I might have very few on the lower end considering how easy it is. So just imagining this histogram shape here, I want you guys to write in the chat, right? I'm looking for participation here. I'm looking, so what kind of description would you give this histogram? Okay, would it be symmetric? Would it be left skewed, right skewed, uniform, maybe unimodal, bimodal? Okay, I'm seeing a lot of left skewed. Very good, right? Our tail is toward the left. So this is going to be a left skewed histogram. Very good. Okay. Again, this is all pretty much speculation, right? We're just kind of imagining these scenarios, but they're very common life scenarios. So, okay, what about the grades on a difficult test? On a difficult test. So same scenario, right? I have my test 60, 80, 100. The difference is now it's a difficult test. Where do you think most of the scores would end up being? If it's a harder test, the difficult test. Okay, so on the lower end, okay, so I may end up having stuff like here, maybe here, here, and then I would probably have a lot less results or scores in, like, I'm not saying that I won't have any higher grades, but most of them might end up being over here, right? Yeah, so in this situation, what kind of a histogram do you think this is? Right skewed, yeah, very good. Yeah, you should be writing these down just for your notes, so you have examples, right? So you should be putting these in your notes, guys. Okay. What about this one? The number of times an IDS student studied during the first week of class. Number of times an IDS student studies during the first week of class. Okay. I'm going to start this at a 0, and then maybe a 2, a 4, and maximum a 6. Okay. First week of class. Remember, how many times did you study during the first week of classes? Yeah, I think we're going to have like an overwhelming amount of zeros here. Maybe a few 2s and 4s. I doubt there's any 6s here, 4 to 6s. Right? I'm thinking this is a high amount of 0. Okay, so what is this? If we have a histogram again, right? We got this going on. What is that one? Again, right skewed. Yeah. Yeah, absolutely. Definitely right skewed here. If I have all of these zeros. Okay. What about the age of cars on a used car lot? What do you think about that? Age of cars on a used car lot. Do you think that there's going to be more of one age than the other? Or do you think there might be a nice mix, an even mix? Okay, so maybe there might be a few cars that are like more, let's say, I don't know, 5 years old, 10 years old, maybe 15, 20, 25 years old, right? Maybe a nice mix of them. So we might have like some here, some here. We might have some here, who knows? Maybe a little bit more here or a little less, not sure, right? So this one could definitely be something like uniform. Okay, I doubt that they're gonna have more in the middle, like a lot older. They usually tend to be like, they tend to be like 3, right? They tend to be like 3 to 10 years old in a used car lot in a dealership. If we're talking like old, like a private used car lot, heck, we might have like a lot more of these older cars. This one's a pretty difficult one, right? Because it's like, it's really hard to imagine that one. I've never been to a used car lot, so I'm not sure. But usually used car lots are based on like their leases that were returned or older cars that were sold back to a dealership against like some credit for a new car. So this one could be any really. It could be like, it could be definitely right skewed if we really thought about it, if it was like a dealership. If it was a privately owned used car lot, it could be uniform. You never know. Okay. What about this one? The amount of time spent by students on a difficult test. Okay. Maximum time allowed is 50 minutes. The amount of time spent by students on a difficult test, with the maximum amount being 50 minutes. So our max is 50. So I'm going to go 10, 20, 30, 40, 50. Are we thinking that it's going to be more on the, is most of our data going to be over here on the high end, which means less of our data will be here on a difficult test, right? Yeah. I'm thinking a lot more kids are going to be in the 40 to 50 range, and then maybe the 30 to 40 range, right? I have a feeling that a lot less kids will be in the 20 to 30 range, and maybe like no kids, hopefully, if they're really dedicated to their test, right? So this is going to be more of a left skew. Yeah, David called, or Dario called it, sorry. Okay, I'm running out of space here, guys. I would use this side, but you guys can't see that I have the chat open on this side, so. All right, what about the heights of students in your high school? Or not, high school band, sorry. A lot less kids, but what is about the, I'm gonna use this area right here. The heights of students in your high school band. What do you think? I'm not even gonna bother fixing that. I personally think that usually there's like a nice like average height for height. So I think there's gonna be a nice peak in the middle, and then it's gonna go pretty much this way. Yeah, because usually with height, there's an average height, and then you have some that are taller, and you have some that are small or that are shorter. But usually, right, this is gonna be our symmetric here, where if I do this, it looks about the same on each side, right? And then this one here, I doubt you guys know anything about this without researching it. So we're not gonna do that one. Okay, so right skewed, Dario? This is right skewed? Or you're thinking this one for G? Ah, okay. Yeah, average salaries. If you guys, if you want, I can talk about that. Usually, most of the teacher salaries are on the lower end of the spectrum, unfortunately. So your teacher salaries would be more on the lower end over here. And then a lot less teachers make anything on the higher end. Okay, so it's definitely going to be right skewed. Okay, we don't make a lot of money, unfortunately. Now, if you compare this to the number of hours of work that most teachers put in, right? Hours of work, it's definitely left skewed. Definitely, most definitely left skewed for the number of hours of work that your teachers put in. Okay. All right. I hope this isn't too crazy. This looks really bad. It's like so messy. I apologize. But we try, right? All right, I'll give you guys like a 2 minutes. It is Khan Academy. It's very much like Khan Academy, except Khan has a better way of writing than I do. Do you guys need time? Anyone need time to finish getting this down? Okay, I'll just give 30 seconds. 30 seconds, and then I'll clear this and move on. Yeah, I bought this from Amazon. It's like a tablet to write on. It was only like $30 or $40, and it's actually really good. It works great. This is just my writing. It sucks. My writing sucks. That's all it is. Or I'm just not fully used to it because I connect my letters too much. All right. So, okay. So let's move on here. Okay. So this is the end of our notes for today. So we're kind of ending quite early, and I like this. So we only have about 10 minutes left of class, which is great. Your homework is to continue collecting nutritional facts. Okay. Continue collecting nutritional facts data for our participatory sensing. I have a feeling that when we get closer to Thanksgiving break, or when we come back from Thanksgiving break, we're going to start working with this data. Okay, so I think it'll actually happen before we even go to break. So we're going to start working with this data. We're going to start using RStudio. I know you guys, I keep saying it, but we're moving slowly so that you guys are getting time to process and you're not getting overwhelmed. Okay, so we will get to RStudio in the very near future. But in order for us to collect data, you need to keep inputting data. Dario asked, do you think we have enough data? I think we're getting there. Okay. I think we're getting there. But here, the way you should look at it is this: the more data we have, the better, right? The more data that's collected from a variety of people, from multiple people, the better. Okay. So I want you guys to keep inputting your snacks. Yeah, you have to keep putting in the same foods. Yeah. Here's the thing, Maddie, you might be eating the same snacks, but if everyone was contributing, right, we would have that variety of snacks that we need. So it is what it is. Just keep putting in your snacks, whatever you eat, if you even if it's the same snacks. Keep putting them in. I think it's even harder because we're at home. I think when we're out, if we were like attending school, we'd be eating a lot more variety of snacks, I think. But because we're home, there is a little bit of like a consistency, right? So it is, that's why it's so important that everyone puts in their snacks. Okay. Also, if you did not finish, make sure you input for your journals for 1.2 for today's lesson. And those of you, if you were the group leader in your group and you made the copy of the slides, make sure that you submit it for your group by 3:40, okay? So make sure you submit, group leaders. You submit it and it will submit for the whole group. So submit the slides for the histogram sort. I can't speak apparently. All right, guys, that's it for us, okay? Go start your lunch early. Enjoy. Take an additional 10 minutes. Take a break. See you guys. Bye.